Hello everyone, this is Marissa Brady doing the PowerPoint slide presentation for Digital Curation LIS 6773. The first report that I did was on Icelandora. Icelandora was created by the University of Edward Island Robertson's Library and is now being used and developed by the international community. Icelandora is an open source software framework that allows users to manage their digital materials such as audio and video files, photos, and PDFs. Icelandora is based on the foundation of Drupal, Fedora, and Solr repositories that help the operator manage their digital content. The solution packs have editors and data managing processes that come in all kinds of different formats. These formats include video, newspaper, audio, book, and PDF solution packs. All of these different formats make it easier for the operator to customize Icelandora to their own preference. If a user wants to compile their photographs together in one place, all the user would have to do is create an ingest form for them. On the ingest form, the operator can create three things: the file name, the object name, and the local identification ID. The option for copyright management and the copyright holders, where you can place the information about the publishers in. You can also use the ingest forms to categorize course catalogs, newspapers, student publications, and thesis for your master's programs. Each of the solution packs have their own set of tools that help the operator create an automatic process that updates the data. This happens every time that the user uploads new digital objects to the repository. The technical metadata is organized through two modules called FITS and PRIMUS. Also helpful is the fact that the metadata on the repository can be used alongside the ingest forms. The ingest forms are manufactured by the XML form developer. All of these forms can be personally customized as well. The metadata is organized by three different ways: vocabulary lists, ingest forms, and default text. The Icelandora codes are all managed by the GitHub repositories and is overseen by the Icelandora Foundation. Members of the Foundation are required to go to Icelandora camps as well as meet weekly on Skype to see if any improvements can be made about the code. If any bugs or problems should arise, there's a Jira tracking system that gives the user the ability to post bug reports immediately to the Icelandora community. The resource that I used for this paper is the Icelandora webpage located at http://icelandora.ca. The second report that I did was on the Global Biodiversity Information Facility. The Global Biodiversity Information Facility is a database repository that is dedicated to giving the user free and open access to the biodiversity data. This database repository is approved by the government and operates as a worldwide open data infrastructure. There are 4 different steps to the infrastructure that the GBIF has that can help the operator use the website to full capacity. These 4 steps are digitalization, publishing, integration, and discovery and access. For the first step, GBIF utilizes digitalization, which is used to secure the information in electronic format. This is done through the use of techniques such as imaging and databasing. Secondly, they apply the publishing procedure, which makes the data sources accessible in a well-known format along with the proper metadata for the website. The third step is integration, which is the practice of aggregating the available sets of data, applying dependable quality control routines, and regulating the formats. The last step is discovery and access, which allows GBIF to create network-wide indexes. These indexes enables discovery services to be used by the operator through the use of web service APIs, making the data sets available for use. There are 4 different types of data sets that the GBIF supports. These are resource metadata, checklist data, occurrence data, and sampling event data. The resource metadata allows GBIF to develop sets of data for individualized resources. It is also a metadata-only class, which enables the user to be able to have access to facts that have not yet been put online. It also makes certain that all the metadata data sets is correlated with a digital object identifier that helps the user to restructure the data user's citation of the resources. Checklist data gives the operator a list of named resources that include information such as local names and specimen citations. The occurrence data has the information about particular native and individual organisms that present evidence of an occurrence of species at a specific place on a precise date. Sampling event data is used to appraise community composition for a wider taxonomic group. These particular sets of data draw from standard protocol that allows the operator to calculate and examine biodiversity such as bird censuses. The GBIF uses a registry as their core component of the structural design, which gives the user access to source of information that is authoritative on the GBIF members, otherwise known as nodes. It also gives off information about institutions such as data publishers and the data sets. Also, GBIF has distributed network systems that provide the user with a central coordinating mechanism. At the core of the registry is the post-GRE database that the users can connect to through the web service API. To be able to search the site, there is an implanted Apache Solr index that is maintained and left out in the open in the API. The registry emits the messages that are sent to the messaging bus, otherwise known as RabbitMQ. The members who hold the data are able to handle the content located in the spreadsheets or in the databases. Then they are able to operate the specific publishing tools to expose the data for query and admit the data over the internet. After the data is admitted over the internet, it is entered into the GBIF registry. Aggregators are put into place to give the user the ability to explore and to get into the data sets. There is a series of processing steps that each occurrence records in the GBIF portal. The messaging system helps to keep the processing codes independent of one another. The processing system is separated into 3 different parts. These parts are crawling the data sets into fragments, parsing fragments into vertebrum occurrences, and interpreting the vertebrum values. The Darwin Core archives allow the user to support crawling of the XML-based protocols such as BioCase. The crawling creates sets of fragments that symbolize a single occurrence record in raw form. Fragmenting also helps GBIF to appoint a stable GBIF identifier to each of the fragments through tools such as occurrence ID or catalog number, along with the dataset registry key to get a new identifier. There are several open source tools on the website that gives the user admission to the data located on the website. The open source tools that are used are called the Integrated Publishing Toolkit, Nodes Portal Toolkit Startup, the Darwin Core Archive Validator, the Name Parser. The Integrated Publishing Toolkit is used for data publishing, metadata authoring, and data discovery. For instance, the Integrated Publishing Toolkit can distribute primary occurrence data, taxonomies, and checklists for species. The Nodes Portal Toolkit Startup was created for the purpose of enabling the user to ascertain a straightforward GBIF-compliant web presence. Then there is the Darwin Core Archive Validator, whose job it is to establish that the Darwin Core Archive Validator acts in accordance with the Darwin Core text guidelines. Lastly, the Name Parser is used for the data cleaning and helps the user to take apart the 3 form names in order to aid the operator in validating that the scientific name is a well-formed three-part name. The resource page that I used for this assignment is the Global Biodiversity Information Facility, located at http://www.gbif.org. The last report that I did was on the U.S. National Archives and Record Administration. The U.S. National Archives and Record Administration contains records that help the user to explore United States history through documents, photos, and records. The mission of the National Archives and Record Administration is to allow continued access to important documents of the rights of the American people and the dealings of their government. In order to preserve these records, the federal government has begun to use the ERA system, or the Electronic Record Archive System. The Federal Record Instance allows NARA to ingest, store, and process long-term electronic records from different federal organizations. It also provides online creation of record schedules that can be in all different kinds of formats, as well as the accessioning of records into NARA's legal custody. In addition to the Federal Record Instance allows different organizations to send electronic records to NARA by offering the user access to the ERA packaging tool. The Federal Record Instance holds 37 TB of federal records, which consists of the legacy holdings and new accessions. The FRI is used by the NARA electronic record staff, the appraisal and the accessioning archivist, and the staff from federal organizations. The Executive Office of President Instances gives NARA the ability to do rapid ingest. It also has the ability to do a search and a retrieval of electronic records from the George Washington administration. It holds 82 TB of data and 250 million indexed electronic records, which is made available for public access so the user can search for the records. There are over 3 million photographs and more than 200 million email messages in the EOP instance. The EOP instance also holds over 30 million other electronic records as well. The Executive Office of the President Instances is being used by over 30 archivists who are responsible for handling this special access request. The Congressional Record Instance, CRI, was created and released in 2009 and specifically designed for the rare requirements that the Congressional Record uses. The reason why it was developed was for the Center of Legislative Archives at NARA. This model enables the users to have the ability to ingest and preserve congressional e-records. There are access, copies, and local references of the information that can be found at the main National Archives building. The information that requires deeper preservation is located at Rocket Center W, West Virginia. The Senate and the House records have ingested over 15.1 terabytes worth of information over the past few years, and there is some more information to come. The resource that I used for this paper is the United States National Archives. Thank you for listening to my PowerPoint slide presentation.